Hello everyone, welcome to this video number 4 on power factor improvement and substation engineering. In this video, we shall learn substation grounding, which is our learning outcome number 4. So what is substation grounding? All of you know what is substation. It is a junction in the power system so as to receive the power and to distribute to various consumers at different voltage levels. Now in the substation, grounding, there are two categories of grounding in the substation. The one is equipment grounding and another is system grounding. So what is equipment grounding? It is the process of connecting the metallic frame of the electrical equipment to the earth. The metallic frame, it is non-current carrying part. So normally at houses, at domestics, we do earthing for connecting the metallic part of the equipments to the earth. Now this is the same earthing. It is adopted in the substation also. All the metallic part of the substation equipments. It may be transformer. It may be your circuit breakers or relays or lightning arresters or surge arresters, all potential instrument transformers. So all those metallic frames, even the fence of the switchyard, that is also, and the structures, the towers, they are also metallic frame. They are all connected to earth by this grounding. Second one is system grounding. In the system grounding, the electrical part of the system, that is particularly neutral of the star connected system, generator and transformers. So generator, star connected generator, the neutral, suppose if I have a generator, then and if it is star connected, then the neutral of this is connected to earth. So this is called also a grounding. Now this neutral, either it is solidly grounded or it is connected through some resistor or it is connected through some reactor also. So in some cases we find a reactor connected to the ground, and this uh, grounding, neutral grounding, it is done for allowing the flow for the fault current, because this fault current will cause the protection system to operate and isolate the faulty part from the system. And even in transformer also we have star connected. We have transformer. Suppose if it is star connected, then the neutral is connected to earth. So this allows the flow of zero sequence current, which is very much required for balancing the fault. Otherwise, the neutral of the neutral will possess some potential, and it may cause the damage to the equipment. So neutral of the star connected system, it is connected to the earth for protecting or for the proper operation of the power system. So here it is a figure shown, that the scheme of the substation grounding, where you can see the equipment. These are connected to, this is called equipment grounding. So the equipment is connected to ground. Even this equipment is connected to ground in this way. Even this equipment is connected to ground. Even this equipment is connected to ground. And substation grounding, you can see this is the neutral. It is connected to the earth. So this is our system grounding. The neutral is connected to earth. Now, why this one more link is provided between the metallic frame and the neutral? It is for reliable operation of the system. In the case if this link fails, then there will be a provision for fault current in this way back to the earth. So these two links for metallic frames provides the reliable operation of the power system. So this all together, equipment grounding and system grounding, is adopted in the substation grounding. Now, what are the reasons for substation grounding? So, in the substation, there are different ways of getting electrical shock. So, it is illustrated in this figure. Let us understand it. Suppose this is the equipment, okay, and uh, this is connected to the, suppose due to some fault, it is connected to earth. Now, when it is connected to earth, then there will be now here there will be a potential of V because of the flow of this current here, because of this flow of current, this potential, whatever potential of this wire is there, that will appear at the ground. Now this potential will cause a current to flow through the earth in this direction, and the nature of the current that is flowing in the ground, that depends on the other many other parameters like soil, water content, and all the nature of the soil, etc. But this current will cause a voltage to be appearing at every point of this earth. And here is shown the voltage profile. Now you can see here, this is the potential, this entire potential, whatever is there, this is entire V will appear at this point, at this electrode. But as you move away from the electrode, then the potential will go on decreasing. So here it is shown the voltage profile of the earth. So you can see this voltage, it is decreasing, and around 20 meter, or depending on the soil, at around 20 meter the voltage becomes zero. Even yeah, ideally it should become zero at infinity, but in practical cases it becomes zero just about 20 meter from the electrode. Now let us understand how the person gets shocked under different situations. So here it is shown a situation one. Now now you can see here, he has it has the steps has some distance between the two steps. There is a distance, and this distance will cause a voltage drop. Suppose here the voltage potential is Va, and here the voltage potential is Vb. So here you can see this Va potential here, and here you can see the Vb potential, and this difference, it is called as step voltage. And because of the difference, he will experience a potential difference, and current will start flowing through his body, and this will cause him to get a shock. And this is what is called situation 1, which is called as a step voltage. Situation 2, when it comes to situation 2, you can see here. Now suppose if the person is standing near to the equipment which is grounded due to some fault, and now what will be the potential difference? Suppose here the potential difference, here it is say Vc. Now you can see this potential difference he will get. So you can see this is the potential difference what he will experience when he comes when he come in contact with equipment which is under faulty. And because, and this potential difference is called as touch voltage. Due to this touch voltage, then the current will start flowing through this body, and he may he may get a shock. And this is more severe than the step voltage. In the step voltage, the potential difference is very small, and the current that is flowing, it will be small value. But if in the situation 2, the severity of the shock is very high because of a high potential difference. Now, this is the third situation, which is called as transfer voltage. So you can understand from here, this is situation 3 is very similar to 2, only the difference is that he is away from the equipment, but he is in touch. He has touched the equipment, but he is away from it. And now you can see what is the potential difference. He will get a potential difference of entire V, which is called as gradient potential rise, GPR. And this potential is very high, and it may cause it may cause the death of the person. So these are the three different situations. So one is called step voltage, another is called as touch voltage, and another is called transfer voltage, where the person get damaged. And to avoid this, the grounding of the grounding is done at the substation. Now, need of substation, the grounding. So, if this question comes, so we can see the one purpose we have seen, the provide neutral of the generator, transformer, capacitor, reactor, connection to earth. As we have seen, when the fault, when the ground fault is happened, like your LG fault, you can see the ground is involved in this fault. Even in LLG fault, the ground is involved. Even in LLG fault, the ground is involved. And when the ground is involved in the fault, then even the other type of faults, we can see the system becomes unbalanced. And when the system becomes unbalanced, then there will be a flow of current in the neutral wire. And if the neutral is not, if the neutral is not maintained at the zero potential, then it may cause damage to the equipment and even may cause damage to the neutral wire. And hence to protect the system from the fault, or to allow for current to flow through the protection equipments, the neutral of the generator and transformer connected to earth. And the grounding, so we have seen the scheme of the substation grounding. It allows low impedance for path for the current coming from the ground and from lightning rod, surge resistors, etc. Then the second one is limit the potential difference that appears between the substation metallic object and the structure and the ground potential rise due to flow of ground current. They may pose a danger to equipment and personnel. The next one is improve the operation of the protective relay. So if we do not allow for fault current to flow, then the protective relay will not be operated. So we have to allow for fault current to flow, and that's why we have to provide a neutral grounding. And then it increases the reliability. If the fault occurs, it may cause damage and it may hamper it will hamper the reliability. It will not be able to supply power to the consumer, so it may cause unreliable operation. If proper substation grounding is provided, the reliability and availability of the electrical system is improved. And also, during maintenance time, some of the equipment they are shut down, but because of high voltage, there will be some charge present on the equipment, and grounding will de-energize the equipment so that you can carry out the maintenance. Okay, so this what I want to say here. If they ask this question, write a short note on substation grounding. So you can write this, and this question they ask particularly explain the different ways of getting electrical shock. So you can explain situation 1, situation 2, and situation 3. And if they ask the need for substation grounding, then you can explain this. So I have explained here the three questions. In this video, up to this only, we shall continue in the next video. Thank you very much.